All right, we are doing section 11.2, which is about calculating probability. And just to get like a very basic definition of probability, I'm not even sure if you looked it up on the internet what you'd see, but Mr. Respetaal's definition of probability is the chance that an event will happen. Right, so like what is the chances something happens? So what would be like, they always say the probability that it'll rain tomorrow is 60%. That means 6 out of every 10 days it would rain, right? Based on the way the current weather is, there's 6 out of 10 chances that it'll rain the next day. Doesn't mean it's guaranteed to happen, but it's just more likely than not. If it's 60%, it's more likely than not. So anyways, we're going to be doing a lot of probability calculations, and there's a few different types. So the next slide here, this probability we had our definition on the previous page, but how you actually calculate the probability is you just take the favorable outcomes divided by the total outcomes. All right, that's your probability. And then some other more specific types are theoretical, is what you expect to happen, and experimental is what actually happens. So the way I explain this is like in the NFL, if every team has equal chances to win, I know that's not true, but they all start with kind of the same salary cap and the same parameters in the NFL. So there's 32 possible teams in the NFL. So the chances the Vikings win the Super Bowl, in theory, should be 1 out of 32. Assuming they have even competition with all the other teams, in theory, they would win 1 out of every 32 seasons. Okay, the experimental probability, however, is they've won 0 out of, I think there's like 54 or however many Super Bowls there have been. Okay, so the experimental probability that they win the Super Bowl is 0 out of 54. All right, so theoretical is what we expect to happen. Experimental is what actually has happened. So this is a lot lower than what we'd expect. Not a lot lower, but lower than we'd expect. Okay, and geometric is just with area, so you'll have a little shape, and like maybe we want a dartboard to land like right in the middle. So you'll take the favorable area of the middle and then divide that by the total area, and that's your chances that a randomly thrown dart will hit in the area that we want. Right now it kind of looks like a donut, but we'll do some of those towards the end. Okay, so we're just going to calculate a bunch of them, all based off of favorable out of total. So we got Joe Mauer here. See if you can figure out the probability that he gets a hit. All right, so the favorable is 25, that's getting a hit out of the total 75. And so that's his chances. And you can write it like that. Other than I would just reduce it, just be 1 out of 3. You can also divide 1 by 3 and write it as a decimal. Or you can move the decimal for twice and write it as a percent. Okay, so any one of those is a way to do probabilities. Oftentimes you'll see them as a percent like this, but theory you can do them as a fraction or a decimal. Any of those would be accurate ways to do a probability. All right, so just another example here. Pause the video, give it your best shot. What's the probability of hitting a white space on this spinner? Okay, so there are 8 total spaces. 4 of them are white. So our probability would be 4 out of 8, or 1/2, or 50%, or 0.5, however you want to write it. Sorry for the poor handwriting there, but that should say 50%. Okay, in the second case, a prime number. So you've got to count, there's again 8 total shapes, and the favorable is the prime. So 2 is actually the only even prime. Remember, prime is a number whose only 2 factors are 1 in itself. So 2 is prime, 3 is prime, 4 is not because it has a factor of 2. 5 is prime, 6 is not, has factors of 2 and 3. 7 is prime, 8 is not, and 1 is actually not, right? Because it has to have 2 factors, and 1 only has 1 factor. So we've got, if I count the check marks here, I think it's 4 out of 8 again. So our probability of randomly hitting a prime is 1/2, or 50% again. All right, some more basic probability calculations. We're rolling die. So I know I have 2 die on here, so I kind of messed this up. But what is the theoretical, in theory, what is the probability of rolling a single die and getting a 5? Pause the video, give it a shot. Okay, so there's one favorable, right? There's 6 total outcomes, 1, 2, 3, 4, 5, or 6. One of those is favorable. So our chance is just 1 out of 6, which is, I think, like 16.7% if you divide it out on a calculator. Okay, and so we can do an experimental probability where we roll it and see what actually happens. Maybe I can't, because oh, there it goes. So we did not get the 5, right? But we'd only expect to get a 5 16% of the time, so that's not that surprising. Theoretical probability of rolling one die and getting a 2 or a 3. Okay, so now we have 2 favorable outcomes, 2 or 3 out of 6. So that probability is 1/3 or 33%, 33.3. All right. Okay, so 2 die gets a little bit more tricky. All right. You can get anywhere from 2 to 12, but getting a 2 and a 12 is more rare because there's only one way to make a 2 and only one way to make a 12, right? Versus 7 is more common because you could roll a 1 and a 6, a 2 and a 5, 3 and a 4, a 4 and a 3, etc. So there's actually a lot more ways to make 7 than there is to make 2 or 12. So the probability isn't equal for rolling each different number when you roll a pair of dice. So if we do getting a sum of 3, right, if we look at that probability, there's only 2 ways to get a 3 out of a total of 36, 6 times 6, so there's 36 different possibilities. Sorry, again, my computer's really struggling here. So that gives us just 1 out of 18, 2/36 or 1/18th chance. 7, on the other hand, is much more likely. If you count these different ways, there's 6 different ways to get 7 out of 36. Okay, so there's a 1/6 chance that when you roll 2 die, you will get a 7, right? Which again, I think we did before is about 17%. Okay, and I put this picture. This is a game called Catan, and I've played this, and you roll die, and it's kind of a game of luck. But my friends get mad because certainly 7 should be more common than 3. But when they play, if we roll a bunch of numbers that are uncommon like 3, they get all mad because there's a difference between the experimental probability and the theoretical. In theory, you should only get a 3 1 out of 18 times, right? But experimentally, it might happen 1 out of every 4 rolls, at which point my friend gets really mad because it defies the theoretical probability. All right, anyways, just keep blasting more probability ones. So you can flip a coin 50 times, get 28 heads, which is higher, the experimental or the theoretical probability. Pause the video, give this a shot. Okay, so I'm just going to calculate both of these. So in theory, heads should come up half the times. So it should happen 25 out of 50 or 1/2, right? That's what should happen in theory. What happened experimentally was 28 out of 50 were heads. So in this case, the experimental is a little bit bigger than the theoretical, a little bit greater. This one was a little bit greater than what was expected. So that's what we'd call luck, right? So if your sort of experimental probability is higher than what you should have got in theory, that's the idea of luck. All right, so this was a survey of 38 students. 14 thought I was funny, and 6 thought Nick was funny. 4 thought both Nick and Westpatal are funny. Find the probabilities. All right, so this is called a Venn diagram. And just a reminder that there's like 38 total. Okay, and so 14 thought I was funny. That's this circle here. 10 that just thought I was funny, and 4 that thought both of us were funny. Okay, Nick's 6 funny people are split into 2 that thought he was just funny, and then the 4 that overlapped and thought both of us were funny. Okay, so this 4 represents an overlap of the 2 circles. So the probability that thought neither were funny, so the total again is 38, and you just have to find out, in this case, the favorable is the ones that thought neither of us were funny. So out of the 38, let's see, there's 16 that are in these circles. So the ones that thought neither of us were funny would just be 22. So it'd be 22 out of 38 or 11 out of 19 if we reduce it a little bit. So a little bit more than half by the look of it. And then those that thought I I was funny but not Nick, so there's 38 total still. That's the same, the bottom's the same. And then thought I was funny but not Nick. That's the ones in my circles but not Nick. So that would be 10 out of 38, right? Or 5/19. Those would be the most astute students, the ones that realize that I'm funny but not Nick. Okay, hopefully that makes sense. So last type of thing then is called a geometric probability. So when you do this, we'll have like an area we're trying to hit, like maybe the bullseye or something, and that'll be the top number in the probability, and then the bottom will be the total. So it's favorable out of total again, just with area. Okay, so we got two questions. So here we're trying to pitch it right into this little square. It's a 4x6 square, and our whole strike zone is 17/22. So we're saying if it hits in the strike zone randomly, what is the chances that if it hits in the strike zone, it hits in the little red square that we want? So pause the video and see if you can figure this out. Okay, so I'm going to go favorable over total. Sorry, my pen is really struggling here. So favorable is just the red area, so 4 times 6. Okay, and the total area is the 17/22. So multiply those two together, and we get 374. So this is our probability, but again, I would probably divide them here, right? So I'd probably do 24 divided by 374, and then do it as a decimal or percent. So it's about 6% if we move it over. So I'm going to call that like 6.4%. So you have a 6.4% chance if it's random. Of course, if the pitcher is a good pitcher, he'll have a higher chance of hitting it. But if it's randomly landing in the strike zone, the chances we hit this little corner is only 6.4%. Okay, last one is this dartboard type question, and these do show up in homework and on tests and stuff, so it's good to talk about. So each one of these little tick marks is 2 inches, right? That's what it means. So each ring is kind of 2 inches, like 2 inches more in its radius. So like we have 2, and then this ring would be a radius of 4, this one would be 6, and all the way on the outside would be 8. Okay, and so what we want to know is the probability that we hit the donut. Okay, and so just a couple reminders with circles. Probability is pi r squared. Okay, and I'm going to pause here. I'm going to have you pause here and try to figure out again what are the chances we hit this blue donut, and see if you can figure out a strategy before continuing. Okay, so the trick is we're going to imagine that this was filled in and find that whole area of that circle, and then we're going to subtract out the middle part. We're going to punch that out, and that'll leave us with the area of the donut. So we're going to do this whole thing, take out the middle part, then we'll have the area of the donut. Okay, so that's sort of our setup. Okay, and from there it's hopefully straightforward. This radius here is 2, 2, 2, so the radius is 6. Okay, so the area is just pi times radius squared, so pi times 6 squared, so this would be 36 pi. And then this thing that we're going to punch out has radius of 2 plus 2 or 4. So radius is 4. And so that's going to be pi times 4 squared, which is 16 pi. And I could do decimals here, but it's actually easier just to leave it this way. So now I'm going to do 16 pi minus 36 pi minus 16 pi. So my ring is actually 20 pi area. Okay, so going back up to our problem, that's the favorable is hitting that ring. Man, my thing is struggling, sorry. So favorable is the 20 pi. Okay, and then we have to do that out of the total. Okay, so the total area, right? Remember, I'm landing in here randomly somewhere. So the total area on that dartboard has a radius of 8. So that would be pi times 8 squared, or 64 pi. Okay, and again, not doing decimals here kind of helps because now my area is right here and I can reduce it. The pi's cancel out, and then 20 over 64, that would be like 10 over 32, and then I can divide by 2 again, so that'd be, oh my word. So that would be the chances that it randomly hits and lands in the blue ring would be 5 out of 16 chance, right? So I don't know, that's a little bit more than 25%. So you divide it on the calculator if you want to know for sure. All right, that's it for probability. Thanks for watching.